Okay, we have a couple new words we have to talk about today. I said today we're going to intro the other two types of lines. We are going to do that today. So we have a pretty easy handle on what we're doing here. So outline today. Okay, we're in section 1.2. Segments and arrays. Okay, segment lengths. So that's what we're talking about. So first thing first, what we got to talk about, we got to actually go through the definition of some vocab words here. So definitions, new words. We have talked about what a segment is. We have to talk about what an array is. Those are brand new. Those are two types of lines we need to discuss. Once we're through those, we got another vocab word. The new vocab word we have to go through is the word congruent. There's a symbol, a notation that goes with that. Those are our new vocab terms that we're going to discuss. If we can get to it, I'll talk about a property, which is segment addition, if we can get here. And I'll basically look at the clock to kind of see. If we don't get to that today, that's fine, because I want to go about 15-20 minutes, do the intro to this stuff. If it takes it long, then go right into those homework examples and give you the rest of the time to work. Because it's due, what, Friday this week? Mm-hmm. So it should be pretty easy. Okay, so that's kind of our idea. All right, let's actually fire away here. What time we got? 10:15? No, 9:37. So okay, yeah. All right, let's fire away. Let's talk about it. First, talk about what a segment is. Okay, a segment is a type of line, so you got to remember that. So first and foremost, it's a type of line. Typically what we call it a line segment. That's another word for it, so AKA a line segment. The book usually refers to them as segments, but a line segment. Definition of it is the distance between 2 points and the points at the end of the segment are called endpoints. So they can get real creative with the name. So endpoint is kind of a new term. So it's the distance between 2 points. So that's the start of a line, right? That's how we defined a line the other day. Distance between 2 points, but extends in both directions without limit. This one doesn't go further. Whatever the points are, those points at the end of that segment, those are called the endpoints. That's where it starts and stops. So no arrows this time. In fact, let me draw one. I'll get out of your way here in a second, sorry. Line segment, no arrows, dots on the ends. It doesn't go past it. There's a definite length to it. This is measurable. In fact, let me put that. You can actually measure this. Measurable. Measurable have an E in it. I can't spell this in my life. That looks goofy. It looks like it should have an E in it. This doesn't look right. You're writing that. Looks like there should be an E in it. But measurable. So it's got a definite length. Like I put a ruler up there, tell you, oh, it's 1.5 feet long, whatever that is. Now, the notation. So the book asks you, hey, name the segment that contains points A and B. Fine, you're going to name the line. You're going to name it. So the notation for it, no, you do not have to always write the word notation in your homework. I know some people were asking that yesterday. I just put the word notation so you know this is how you're supposed to answer your question is whatever I write underneath it. If you're going to write a segment, you write the 2 letters that are on the segment, The 2 endpoints, you have to write the endpoints, by the way, not weird points in the middle. 2 endpoints, and then put a bar above it. No arrows on the bar. Now, you can switch the letters around, I don't care, but you have to use the endpoints. Don't use like the weird points in between, because there could be some letters in between them. Okay, now, here's the goofy part. This is the big thing. I'm going to put or, you could write it like this. You could write AB and put no bar on the top. The big difference here, why there's 2 ways of doing it. This is the only type of line that you can choose not to put a bar above it. The only reason. Typically, when they put the bar, this is actually talking about the actual drawing of it. So we're referring to the actual picture. This is referring to its actual measure. Like how long it is. So if they leave the bar, they usually talk about like how long that stick is. That's usually what they do when they're in the textbook. They're like, oh, they're forgetting the bar on this a lot. They're probably talking about how long it is. Like they're referring to the length of that stick instead. But they're the same. I mean, they work both ways. Okay, questions with what a segment is. So the other type of line. So the first one is called a line. It's self-entitled, had arrows. This one doesn't have arrows because it has a starting and stopping point. The last type, which is called array, is like a weird hybrid blend between them. So array is a type of line, the last type of line. There's no other words we use for array, it's just called array. But the definition is the distance between 2 points and extends in one direction without limit. The other end contains an endpoint. So it's a type of line that has one endpoint and one arrow going one direction. But it's still the distance between 2 points, right? Because you have to have 2 points. It's the type of line. But it will keep going in one direction. So this is non-measurable. It's too long. It goes forever. But it has a starting point, has an end point, that type of thing. So array is typically the one that most people probably have seen since, since algebra or pre-algebra or any general math, because this is what it looks like. That's array. Now typically we put 2 dots on it. So I'll draw it like this, C. It doesn't matter where it's tilted. Now, if you're going to go into like physics or any type of sciences, there is things called vectors. Vectors kind of look the same way, but a vector has a definite direction and magnitude to it. But this is a array. It's just representing a line going in a certain direction. Now, how you write it is the big deal. This is the one, like in all of the types of lines, all 3 of them, the array is the one that most people mess up on. They'll get it wrong on a test, on a homework assignment, because, yeah, it's got 2 dots, right? You have 2 letters, but the arrow has to face a certain direction. Because you can still do the same thing. You can switch the letters around, C and D, D, C, it doesn't really matter. But when you draw the arrow above it, because you have to draw the mock picture above it, the arrow has to go a certain direction. Okay, so let me explain. So if you're going to choose to do the notation here, so notation. Notation for a line, or array I should say. 2 letters, again, it has to be 2 letters, not more than 2, it has to be 2. So I'm going to go CD, and above it you have to put the arrows. Now, where's the end point up here? Where's the ending? C. So when you draw the mock picture, the endpoint better be above the letter C, like this, and the arrow goes above D. Wherever the endpoint's at, that better be above the letter when you write it down. Now, if you're that person that likes to switch the letter around, because it doesn't matter the order you write the letters. So if you write DC, you're that person that wants to do it that way. The endpoint has to be above the letter C, because that's where the endpoint is. And the arrow's going through D. It's passing through it like a shot through it. So boom, the arrow better go through D. Those are the same name to me. The number one thing people get wrong is they put the arrow facing the wrong direction because it matters in what order you write the letters down. So how I always think of it is, where's the endpoint? Endpoint's at C, and make sure the endpoint's above the letter C no matter how you write it. That's the fail-safe way you never get it wrong at that point. We'll use raise a lot in the later sections. Questions, comments about that? Okay, probably the last word I want to discuss today, because we won't get to the segment addition stuff yet. The last word I want to talk about today is the word congruent. Okay, the final word, then we'll go to a couple examples of the homework. So the word congruent. Congruent's a word we use in geometry strictly for math. Everything else in math and algebra 2, pre-calc, we always use the word equal. Right? Oh, you're equal to, or it's an equation, we have an equal sign. The word congruent is used in geometry because it's equal, means equal, in size, shape, and measure. Now you're probably thinking, Ward, you just said the same thing, just multiple different ways. Size, I'm talking about proportionality. So if you're proportional, you can be roughly the same size. Roughly, like what I'm saying. Shape, overall shape. Like twins can have the same shape, they can be proportional, but they're not exactly equal, so they're not exactly congruent because they have different brains and they have different personalities and stuff. The measure, everything has to be spot on. So not just proportional and generally the same size, everything down to the finest detail has to be exactly the same. So everything has to work. Proportionality, the overall shape of the object, and the exact measures of it. So that's what makes things congruent. There is a little symbol we have for things that are congruent to each other. It's an equal sign, but we put a little squiggly above it. I call it a tilde because it's on a keyboard. It's right next to the number 1 key on a keyboard. But it's right above the equal sign. It means things are congruent. So why we have this symbol and why we have this word in geometry. Objects, shapes, can be congruent to each other. Math, like x plus 4, can be equal to other things. So in Algebra 1, this is what you do. Right? You can do that in Algebra 1. But in geometry, we use the congruent sign when we're comparing the pictures. Like AB up there. AB, the actual segment, could be equal to a different stick on the board. Maybe up here I have a stick EF, and a stick up here EF. Maybe they're exactly the same size. So they're congruent to each other. Do we see why we use the congruency symbol? It's comparing the pictures, not the math. We use equal signs in math. We use congruent symbols in geometry when comparing the shapes itself. So that's the difference. But again, for that shape and that shape to be exactly congruent, there's size, shape, and measure. They're both segments. They're both roughly the same size, but when we measure them, maybe they're exactly the same. Maybe they're both exactly 1 foot in length. Okay, do you see the difference, why we use it? Okay, let's talk about homework today. So that's all the new stuff today. We'll get to this segment addition stuff tomorrow. We'll do some drawing. We'll do a little more hands-on. I've been lecturing too much lately. We'll do a little more hands-on activities tomorrow. Alright, so let's go through some homework here. This is your first picture, right? Like problems 1 through 3 or something like that in your book. So, yeah. Okay, all right. So let's talk about this picture here. All right. So what you're looking at here, this is the picture in the first couple problems in your homework. Now, why I bring this up? The line L is right there, because you can see the little L at the top. You can call it line L, or you could call it RZ, I guess, and put the little arrows above RZ. Do you see there's a weird dashed line on it? Because what's happening here is RZ, or line L, whatever you want to call it, is poking through the paper. Poking through the paper. So, thank you, yeah. So if they show dashed lines in the future, it means it's three-dimensional. So Z is like down here where my pencil lead is. R is right where the pencil's actually touching the paper, and L is like up here where the other arrow is. So they're trying to show that it's poking through, so Z is not even on this plane. It's like way down here. I know it's really hard to show three-dimensional stuff. So just be careful of that. But again, you can call that line anything. I think one of the questions says, hey, where does line M and line N intersect? They intersect right there, right? But how would you say that? Where would N and M, the lines, intersect? What's the answer to that? Say it. Point Y. You have to write the word point in front of it. If they want another name for a line, I think one of the words was give another name for line M. So if they want another line, or name for line M, what's another name I can check? XR, perfect. XR, put little arrows above it. You can call it XY for all I care, put arrows above it. But these are different names other than that one. I think one of the questions was, name the plane that contains W and R, or something like that. Name the plane. Well, there's a bunch of different names you can call it. All these dots are on the plane, right? They're all on it. So just pick any three that are not in a straight line. So pick any of those three dots, not in a straight line. So pick three right now. The three dots I just touched. Pick any three.
Good.
So here, here, and there. Pick three.
YWR.
Perfect. YWR. And how do you name that? You write plane YWR. That's the name of the plane. You could call it YWRX. Now I know you're thinking, Ward, you just told me I can't pick ones that are in a straight line. W wasn't in line with Y and R. They're making an L shape. You're fine. I can name all four as long as at least three of them are not in a straight line with each other. So bare minimum of three. Okay, so that's your plane. Now there was another name for that plane. Instead of calling it XYRW, or whatever that thing is, this is weird. I didn't talk about this yesterday. You could call it plane B. That's a cursive letter over in the corner. That's the name of the plane. You can name planes with cursive letters because they put them off on the side. Now here's my question to you. Is point Z on that plane B? No, why? Yeah, it's going down. It's like way down here. Z is back, it's down here. It's below the plane. It's on the line poking through it. It's not even on the same surface. So just be careful with this. Okay, second one's, I think the second picture you guys had, where's my cursor at? Oh, there it is. What? Working. We'll do whatever you want. Do whatever you want, computer. Seriously, just go to the next picture. Aha! Oh my gosh. What a travesty, it just worked. Alright, whatever. Okay. On that picture, it's three-dimensional. It's supposed to be like a triangle wedge. It's kind of like a provolone candy bar thing. You know, it's a triangle cheese kind of thing. They have dashed lines there. I just want to zoom in for the love of God. Just let me zoom. All right, so the dashed lines means they're in the background. So there is a bunch of different, what they call faces or planes, walls, whatever you would call it. There's the front of the triangle. There's the back triangle, that's like in the back. So it's like a tent. Think of it like a tent. So you have the front, the back of the tent. You have this wall over here of the tent. You have this wall right here of the tent. And you have the bottom, the floor you're going to sleep on. So there's a bunch of different faces to it. I want to know 3 points that are collinear. 3 points on that picture that are collinear with each other. What are they? Please.
Point A, point H, and point B.
Boom. Perfect. That's a good example. Point H, point A, point B in no particular order. A, H, and B. They're in a straight line. That's what collinear means. They're in a straight line with each other. You could have picked B, J, and F. As long as you're in a straight line. Now, that's pretty easy. And again, how I wrote that. Points A, comma, H, comma, B. Okay? Now, here's my question. A, H, J, and C. These points. So do you see all 4 of those points? Are they on the same plane? A, H, J, and C. No. Here's why. A, H, and J, sure. These are on this wall of this tent over here. That wall, it's like this side of the tent. C is way over here. It's on this other side of the tent. So if I'm looking at the tent straight on, C is right here. So here's my tent. But the other wall that I have drawn here is this wall over here. This is where A is sitting, J is way back there in the back, if I'm looking straight on. So yeah, they're not on the same plane. They're not coplanar. Because they're on different surfaces. They're in the same space, but not on the same plane. Okay, questions at all about what they're asking here? Okay, the last thing I want to talk about, and I'll give you some time to work. It's 10 minutes-ish. Alright, nope, not that one. This picture, I think this is like one of the last problems you have like, with an actual picture. Look at line P. Line P, it's this one going down here. Line P. It's poking through both pieces of paper. So like this is a plane, and that's a plane, and P is the one that's poking through, it's like this. So the pencil is line P, and my hands are the 2 planes. They're almost parallel to each other. I know it's really hard to see that. Okay, does that make sense? P is going through. So P and D are way up there. There's like where my eraser is. So they're off the planes. M is off the plane. I know that's really hard to see that. M is not on this plane. Because it's right, so if I have the 2 planes, M is in the middle. If I were to break my pencil right here in the middle, that's where M is sitting. It's between the 2 planes. I know that's really hard to see that, but the only reason I know that is because it's poking through, you can see it. It's poking through, so it's floating, even though it doesn't look like it. So M is not on plane Q. So be careful of that. Questions, comments, concerns? Perfect, you have the rest of time to work today. We're going to consider E2. We'll probably have a meeting maybe on Friday this week.
Okay.
Okay?